Okay, today we're going to work more with identifying the domain and the range and the solutions of a quadratic function from its graph and identifying parts of a quadratic graph. So this is a lot like your video on Monday, but we're going to add a little bit more to it as well. So on Monday, you learned that if you're going to solve a quadratic equation by graphing, that you look at the x-intercepts. So if you see this first graph here, this is the graph of y equals x squared minus 4x plus 3. And if I wanted to say what the answers were, I would look at my two x-intercepts and I would say, well, x equals 1 and x equals 3. But I want to talk about why. Why is that the case? The reason those are your solutions is prior to your quiz, when we were solving, you were given a problem like x squared minus 4x plus 3 is equal to 0. So now notice they're flipped around, but that 0 is your y value, right? You've just substituted in a 0 for the y. And by definition, if your y value is 0, then you're a point on the x-axis. So we can solve this by factoring. If we go back to methods we learned before your quiz, right, we'd have an x, and what two numbers multiplied to be 3 and add to be -4? Those are -3 and -1. And when we solve each of these, x minus 3 equals 0, which again gives me the answer of +3, and x minus 1 equals 0, so we again get x equals 1. So it matches our two answers that we got from the graph as well. And again, it's just by definition. If the y value is 0, then that coordinate point is an x-intercept. So that's why graphically we can just look at the graph and say, okay, find your x-intercepts. Those are the solutions to the function. Okay. All right, so now we're going to use the exact same graph, but I've just put it again down here, and we're going to answer all of these questions. We're going to identify the vertex and everything listed, and we're going to try to color code to help us out. So change to blue. What is the vertex of this function? So remember, by definition, a vertex is a maximum or a minimum point. And so on our parabola, it is right, turn my pen on, it is right here. Okay, so all I want are the coordinate points of that. Coordinate points for that vertex would be 2, -1. Okay, now is that vertex a maximum point or a minimum point? Again, kind of think about a roller coaster that you go on. You start up here at the top and it goes down, 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 down. You get to the bottom and now you're going back up. So that coordinate point is the minimum point. That's the lowest that you're going to go. Okay, y-intercept. By definition, that's where it is your parabola across the y-axis. So on the graph, that is this green point right here. And I covered up the number, but I'm sure you guys can figure it out. That's at 3. But we don't write just 3, we write it as a coordinate point. Very similar to x-intercepts, okay? If you're a y-intercept, the x value is always 0. We went up 3. And that piece of information is going to be important for an upcoming lesson. So make sure you're really kind of letting that sink in. If you're a y-intercept, your x is always 0. If you're an x-intercept, your y is always 0. Okay, speaking of, the next part is zeros. Now, zeros, remember, is just another name for your x-intercepts. So looking at the graph, we actually already identified these above, and it's at 1 and 3. Now, you're going to want to get in the habit of writing these as coordinate points. So if I'm an x-intercept, it's my y value, that's 0. So I would have 1, 0, and 3, 0. Axis of symmetry. By definition, that is the line that would cut the parabola symmetrically. So it's going to go straight down the middle. And another fun fact is because it goes through the middle, it's got to go through the vertex. Your vertex is always going to be in the middle of your parabola. And I think some of you have started to recognize that. So we draw the line that cuts that parabola in half, and it's always going to be vertical. And now we need the equation of that line. Now it's a vertical line. How do the equations of all vertical lines begin? It's x equals. And then what is the x value that it goes through? It's x equals 2. Okay, domain. If you've been listening to Monday's video, the domain of all parabolas is going to be all real numbers. Because as I'm going left, so draw an extra line, I'm not only going up, I'm also going left. And on this right-hand side of the parabola, even though I'm still going up, I'm also going to the right, little by little by little. Now, for notation-wise, you can say all real numbers, and for the most part, we will accept that answer, but you need to also recognize that that is from negative infinity to positive infinity. And those are in parentheses because with interval notation, the parenthesis represents a number that you are approaching but will never equal. So it's important that you have the right notation on there. Those are parentheses. Okay, range. Range describes how does my graph behave as it goes up and down. Well, for this one, I have a minimum point, which tells me I am not going to go any lower than this line here. I'm not going to go any further below that. So that is a horizontal line. So we know we're looking at a y, and it's not going to be equals because I don't have points on just that line. I have points on that line and above. So we want to think greater than or equal to. And what is that y value? -1. Now, for interval notation, we know that the -1 is not going to have a parenthesis. It's going to have a bracket because we can equal the -1. Now, I use all y values -1 and above because my parabola is above that orange line that I've drawn. So when you do interval notation, you have to remember that your left value is the smallest and the right value is the larger. So we are going from -1 to positive infinity. So we would write it as a bracket, -1, going to positive infinity. And then infinity has the parenthesis because we can't equal infinity. We can only approach it. Okay. Last part of this one is use the solve by graphing method, determine the solutions of x squared minus 4x plus 3. Well, notice this right here is the same thing as up here, only it's equal to 0. And again, if we're going to solve by graphing, if it's equal to 0, we are looking at our x-intercepts. So for this problem, we'd be looking at x equals 1 and x equals 3, which is exactly what we did in the problem above, right? We're just reviewing it one more time. Now, these ones aren't as a coordinate point because we want an actual value of x that would make this equation right here true. So if I plug those in, I'm going to get 0. So like if I plug in 1 squared minus 4 times 1 plus 3 equals 0. I ran out of page. Okay, order of operations, 1 squared is 1. 4 times 1 is 4 plus 3. I'm hoping that that gives me 0. 1 minus 4 is -3, plus 3 is indeed 0. So if you want to check some of these, you are able to. Okay, do a quick check and you can really know if you've got it correct. All right, so we're going to go through a couple of these down here. I've got 2 problems left, and I'm going to have you guys pause the video. You're going to look at the graph, and you're going to see, can you identify the vertex and all the questions related? Then hit play and come see if you got them correct. So pause the video right now and try these on your own. Okay, if you are done trying these on your own, your vertex is the coordinate point, oops, turn my pen on, -2, 0, right? And that is this point right here. Is the vertex a maximum or a minimum? This one is a maximum, because if you think about it, you're riding a roller coaster, you're going up, 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 you get to the very top, and then it shoots down. So that is a maximum height. That's the highest that it's going to get. All right, Y-intercept. That is this point right here in green, which is 0, -2. And again, make sure you are putting parentheses around these and you're not just listing out some numbers. You have to have parentheses on it. All right, zeros. Just for fun, instead of zeros, let's call it something else too. So we have zeros, we have x-intercepts, and then there's a third name. Do you remember what it was from Monday? It's called roots. Roots. It's the same thing as zeros. It's the same thing as x-intercepts. Okay, now for this one, the only place that it crosses the x-axis is that same point as your vertex. So it only has one root, or one x-intercept, or 1, 0. So, and we also talked about that on Monday, that if you do only have one x-intercept, that it has to be your vertex. Considering that this is a U shape, that's the only place on that parabola that can only hit the axis one time. All right, axis of symmetry. And draw it in. And that would go right there. And that would be the line x equals -2. Okay, domain. It's all real numbers. Also displayed as from -infinity to +infinity. Range. So again, we're going to think about, well, what line do I not go any further than? And that is this line right here, which is my x-axis, right? So how do I express the equation for the x-axis? Well, it's a horizontal line. So we know that it's y equals, well, go back, not equals. It's going to be less than or equal to, because I am below that line. And then I go through y equals 0. Now this is a less than sign. So the highest that I get for y values is 0. And then after that, all the y values for every point on that parabola are negative. So I'm going from 0 to -infinity. Now, which one of those numbers is bigger, 0 or -infinity? It's your 0. So you have to list them from least to greatest. So the -infinity would be listed first, then the 0 with the bracket. Okay, because -infinity is smaller than the 0. Okay, now solve by graphing. So again, it's asking you to solve 1/2 x squared minus 2x minus 2 equals 0. That is the same as the equation at the top of the screen. So solving it equal to 0, that's just my x-intercepts. So in this case, x equals -2. And I can double check it, right? If I plug that answer in for all the x's in this equation, oops, drop my negative, that will be important. -2, I'm hoping that this gives me 0. Order of operations, -2 squared is a +4. Negative 2 times negative 2 is a positive 4 minus 2. Negative 1/2 times 4 is negative 2 plus 4 minus 2 does indeed give me 0. Okay, and that is the only solution for this equation. You guys saw before your quiz that sometimes you do only have one solution. Okay, last one. Try this one. Okay, again, pause the video, try it on your own, and then press play to check your answers. Okay, so for this one, your vertex is at 1, negative 1. It is a maximum. Your y-intercept is right here, which is 0, negative 2. Now for your zeros, or your roots, or your x-intercepts, this one does not cross the x-axis. So you can write none, right? There are no x-intercepts. You're not necessarily going to write no solution for that because it's not asking you to solve. You're just identifying. So you're just going to identify that there are no x-intercepts. Axis of symmetry. I cut this parabola in half. That would go through the line x equals 1. My domain is going to be all real numbers, or negative infinity to positive infinity. My range, okay, I'm going to draw that horizontal line. I don't go any higher than that. So I know that I'm going to be approaching negative infinity. And the high, oops, that's an infinity sign. And the highest y value is negative 1, and that's going to have the bracket because I can equal negative 1. Last but not least, solve by graphing method to determine the solutions to this equation. That is the same equation as what's above the graph, thus that's what's graphed. Now, because we don't have any x-intercepts, this one would be no solution because that one asked you to solve. Okay, there is not an x value that I could plug into that equation, evaluate using order of operations, and it become 0. Okay, if you have any questions at all, make sure you are conferencing your teacher and getting help on anything on here that's not making sense.